so before we begin, I know there's like a lot of sessions going on, so let's be very upfront about what this session is. We're going to go through end to end what the Mosaic AI platform is and all the capabilities in it and why it's like differentiated. So if that's not what you want to hear and like see demos of, feel free to go to a different session. Just want to be clear, like, hey, that's what the session's about, because I know some of the session titles is a little hard to tell like what they are. So that's what this one is. So we're just gonna dive into like what the Mosaic AI platform is. We're gonna show different demos of all the capabilities and try to go through end to end what all the different capabilities are. So it's gonna be like a whirlwind tour. All right, with that, we're now live. So let's get started. All right, so hi everyone, I'm Casey Uhlenhout. I'm a product manager lead on the Mosaic AI platform team at Databricks. We're gonna hope this session is a little less interesting than the keynote this morning. So let's go ahead with that. So we will be showing some things that may be on the roadmap or haven't been released yet. So please just safe harbor statement on all this. And with that, let's get into what is the Databricks Mosaic AI platform. So there's sort of like three main things that we're trying to allow your organizations to do with the Mosaic AI platform. The first is allow you to experiment across all the different types of models that are out there. So we're trying to provide a model agnostic and framework agnostic platform so you can quickly experiment with all of your GenAI capabilities. We then want to allow you, as we alluded to in the keynote, we want you to build quality compound AI systems that leverage your enterprise data. And then you need to operationalize the system. And so we're going to show you how you can evaluate and all of those things in here. All right, so let's start from the beginning. So what are we gonna do that's gonna allow you to experiment across your models? And I'm gonna have some basic slides. We're gonna try to breeze through them and then just go into the product the whole rest of the time. So I thought this slide was a little bit interesting to share. I had to like kind of anonymize the data because I don't know if I'm actually allowed to share it. But our customers on the Mosaic AI platform are rapidly adopting new open source models. So every time a new open source model is released, the on-ramp of how quickly people want to experiment and try these models is like very steep. But the problem that happens here is that if you're on like a platform team, you're trying to like expose access to different GenAI models to your organization, like every model has like a slightly different query interface. More and more they're starting to adhere to OpenAI, but all of them like Mistral's slightly different. It has a system prompt or not and all this stuff. So it's hard to kind of create standardization across all these models. And then every model typically has to go through your own internal review in your organization before you release it out to people. And then somehow you have to let your organization know that a new model is even available for them to use. So this is sort of the problems that we're seeing a lot of our customers have. And so what we're trying to do to solve that is, one, we have this new Mosaic AI homepage, which I'll show you in a second, that will show you all the models that are accessible on the Mosaic AI platform. And we've actually taken a curated set of models and we went ahead and we put them in a system.ai catalog in Unity catalog for you so that you can access all these curated models. They're already wrapped in MLflow, which means you can easily serve them or use them in our fine-tuning solution. Without having to do any other changes. And you don't have to like keep downloading things from Hugging Face and trying to load them in a notebook and stuff like that. They're already in this catalog for you for ease of use. So one of the things that is really important that we work on is our model serving. So our model serving provides a standard query interface for models. So we basically created a wrapper API around every GenAI model so that you can query them all through the same standardized interface, and it matches just what OpenAI's is. And so you can just easily swap out all the models underneath. It doesn't matter if it's an open source model, a fine-tuned model, GPT-4, 3.5, Claude. It doesn't matter which one, you can swap them all out easily without having to make major code changes. And then we also provide a series of models to help you get started in experimenting quickly through our foundation model APIs. So this is where the foundation model APIs kind of have two modes. One that has token-based access. So there's a subset of the models that we're going to give you this like cheap token-based access to. So it's like kind of pay for play as you experiment with them. But the curated set of models that we support with that is not stable, I would say. I probably shouldn't use that word, but it can change. So as the state of the art changes, we're then swapping out which models we give token-based access to. So this is meant to be your proof of concept API to access those models. If you truly want to use these models in production, you need to switch to provision throughput where you're getting dedicated compute for those, and then you can get more guarantees on your latency, availability, and performance with those models. So we'll show that in a second. And then the last thing we're going to show is, again, because we have the standard query interface, or standard query interface across all of our models that are accessible in the platform, this means we can create the AI playground. And so you probably saw that in the demo earlier today. In the AI Playground, you can chat with any model. So you can chat with external models and like these third-party model providers. You can chat with your fine-tuned models, and you can chat with open source models, all in the same environment. You don't have to do anything extra. And so the Playground is a great opportunity to do these vibe checks with your models and prompt engineering. So with that, okay, enough slides. Let's just go inside of Databricks. So if you go in Databricks, the first thing you can do is we have this new tab that you can click in the new homepage. If you need to, you might need to turn on the new homepage, which you can do by going into like the developer settings in here. And so if you turn this on, this is where we're able to sort of advertise to you what the latest models are that are supported on our platform. For example, Llama 3 came out, I guess like a month ago-ish. And so that is up here. So now you can see that, hey, does Databricks support Llama 3? You can see that immediately in here. And so these are sort of the most popular recent models that we have. And then you can see other featured models in here as well. So we do support GPT-4, we do support GPT 3.5, we support like AI21 Labs, Bedrock, Palm models. All of these are actually accessible inside of Databricks, and so you can find them all on this homepage. There's one thing where this homepage is still a little bit work in progress, so it doesn't have all of them because we didn't have the ability to scroll yet, but that will be coming soon. So you can discover a lot of things there. We can also go into the catalog, and to see that curated set of models that I was talking about, we can go into your system catalog. And so if you go inside of system, there's now this AI schema. And this AI schema is basically like our model garden. And so if we click into model, it defaults to tables. Soon it will fix to models. And so if you go in here, you can see all the different curated models that we provide for you in here. And the Llama models will be added in here soon. There's just a minor glitch with Azure that's preventing us from getting this in sooner. So once that gets fixed, you'll have all the Llama models in here. And then all of these then make it easy to deploy as a model serving endpoint. So just to like show you that really quickly, you can come into model serving. And then once you're in model serving, you just say you want to create an endpoint. So I click in here. And then when you come to choose an entity, you're choosing a Unity catalog model. Let me zoom. All right. And so in here, you're just basically going to like find things from the system.ai catalog, and then it makes it super easy for you to deploy any of these with your provision throughput access. So that's what the real benefit of the system.ai catalog is. If you are on the platform team and you're like, I don't want anyone to use the Llama models, I don't want anyone to use Mistral, you can also, not right now, but very soon, you'll be able to actually control the permissions on those system.ai models. And so you can say no one's allowed to use, I don't know, like no one can use Llama 3 until it passes our security review internally. And so you can actually shut down the access, and that will prevent people from serving that model as well as fine-tuning that model. And so you can kind of use this AI catalog to also be, as a platform team, you're kind of like bottleneck to making those models more accessible to the rest of your org. Not that we encourage that, because we definitely want you to democratize access to GenAI, but if that is a concern for your organization, that's what you can do there. And then the best way to show this standard query interface is just to go into the AI Playground. The way the AI Playground works is you can do quick vibe checks in here. You can change your model parameters. So this is showing actually the new Shutterstock model in here. We don't need to do another live demo of image generation. This takes years off your life. So instead, we can come in here and you can choose DBRX instruct. We can come to this little plus sign, and so we can add another one. We can choose Llama 3. And then we can come in here and we can access one of the GPT models. So I can come in here and access GPT 3.5. And so this is using my external model capability inside of model serving, which is basically we're just wrapping up we're basically just proxying to OpenAI for you. So you have to have your relationship with OpenAI. You share your credentials with us. We do secure credential management around it and basically just proxy to it. But we basically wrap it up so that you can easily swap out the models behind things. So in here, I can do that. I have my chats synced down here, so then I can say why is Databricks the best company? In one sentence, because these things can be a little chatty. All right, so if I do that, then you can see all the responses, and then you could see them all side by side, test them all, get quick vibe checks. We also tell you hey, what was the time to first token? How many tokens per second was it? How many total tokens did it use? And you can visually compare across all of them to get rough ideas of which model is the best for your use case. And so we'll get to this a bit later, but as we mentioned, most people are moving from these like huge monolithic models to AI compound systems. And so what ends up happening when you modularize your applications into these like smaller subcomponents, different models actually end up working better for each task. And so you need to be able to quickly experiment, vibe check, and compare these different models to figure out which one is the best for your use case. All right, so that was a quick demo of like how we're trying to make GenAI more accessible to people on Databricks. So it's like easier to find all the AI capabilities or which models are supported. It's easy to play with them, and it's easy to swap them out in your applications. So back to more slides. All right. So here's a scenario that we've heard from some folks. Okay, you made all these models super accessible. Everyone's using GenAI in my organization. It's great. But then an important like POC that we had crashes because rate limits were hit. And then someone spent $40K on a query on a billion row table. So someone ran like ChatGPT or GPT-4 on a billion row table, and now we have this huge bill. And then someone is leaking sensitive data to a third-party model provider, which is violating our terms of service in our organization. And so you're like, what the heck? And so what you do in this circumstance is you shut down all access to GenAI in your org. And so this happens actually pretty frequently in our customer base. And so we're trying to help prevent this. And the way that we're trying to help prevent this is with the AI gateway. So the AI gateway, the best way to think about it is it's Unity catalog for model APIs. So it's basically going to be a centralized governance vehicle where you can control who has access to your model APIs. You can rate limit them. You can turn on an inference table, which does payload logging, so it captures all the data that's going into the model API and capturing the data that's coming out. And then you also get usage tracking, where you can see who is calling the model API as well. So you can, one, do chargebacks, or two, just at least figure out who you need to change the rate limits for. And then we've also added the ability to add guardrails to these. So you can add guardrails to the endpoint itself, or you can add it just on the request. So as you're sending in requests, you can say, hey, I want to make sure that this is safe or not safe. So the AI gateway, for those of you who have been like kind of on our GenAI journey, it used to be part of MLflow, and then it used to be part of model serving, and now we've like ripped it out entirely, and it's kind of just sitting on top of model serving so that all endpoints can eventually be governed with this. The vision of where we're trying to think about going with this is even like vector search endpoints, your Lakehouse apps, pretty much anything that's an API service can then be governed centrally with the AI gateway. So that's kind of where we're heading with this, so that you don't have to build and manage these gateways yourself and support all the new models, et cetera. We just do it for you. Unfortunately, I don't have a great demo of this because the only thing that exists right now in this very moment is the permission and rate limiting. But I can show you kind of a sneak peek of where we're going. So if you did see in here, you can see that right now in preview, you can add these safety filters to your endpoints in here in the playground. And then AI Gateway, I believe, is being like released in like a month, that in like a public preview where you can now actually turn on all of these different features, and they're more grouped together. So right now, like the features are scattered everywhere, but they're gonna be better packaged together. And so the way that you'll see those is when you go into model serving. If I click inside one of these endpoints, the way it exists right now is like this payload logging that captures all the inputs and outputs. Right now, the inference table feature is like part of the endpoint, and we're actually pulling it out into the centralized governance instead. But that's where you're going to see it. And so this repackaging of like the permissions, the rate limiting stuff, it's currently on the endpoints in here. And then we're going to actually change that. So to show you what an inference table looks like, hopefully this one's a good example. We can show this in here. And the power of an inference table or payload logging table is that's going to capture all the incoming requests, all the outgoing responses, unpack them in a Delta table, and then you can actually monitor that to see how your model is performing in production. Just gotta load some sample data. All right, so you can see in here, like sends the Databricks request, has the date, the timestamp, the status code, so you can look up exactly which calls or requests were failing. You can see how long it took to execute. And then here it has like the request that was coming in. And so you can see this is from our cookies. The response, the sampling fraction, any metadata that was passed around in it. So the metadata can include, which model was hit, endpoint name, which model version. And this is important because this actually allows you to do really easy A/B testing. So we allow you to do traffic splitting on every endpoint, and so you can actually see which model was hit for each request that came in this inference table, and then that allows you to do your further statistical analysis on which model is performing better, which is especially important because it seems like in GenAI, a lot of people go straight to prod. They're like, I don't know if it's good enough. Just ship it to 10% of the people and see how it goes. And we're actually going to ship 2 of these models at once, and then we'll let them tell us which one's better because we don't know for sure. And so that's where this inference table really comes in and is really important, is to be able to do that. And then as we'll get into in a second, this inference table is now a rich set of data of what questions your users are asking and sort of what are good responses. And then you can use that to create fine-tuning data sets, for example, or evaluation data sets from this table. All right, so that was the AI Gateway. Again, the repackaging is going to be coming out in a month. But just a heads up, this is what AI Gateway is. It's a centralized governance, and it's going usage tracking, the repackaging, and the AI guardrails are coming out, I think, in a month, basically. All right. Oh, that was the demo. OK. So that's how you can experiment across models in the Mosaic AI platform. So we try to make it easy for you to keep up to date with all state-of-the-art open source models, as well as the ones that are out there in the third-party ecosystem. We try to create a standard query interface for you to easily be able to query them all, swap them all out in your applications. And then because we want people to be able to democratize this securely and safely, we provide the AI Gateway that sits on top to allow you to govern all of them. All right. So now how do you build quality systems with your data? So this is kind of, if you couldn't tell, this is kind of the crux of what Databricks' philosophy is when you're building GenAI applications, is that the way that people used to think about this is, hey, what model do I need to use to build my GenAI app? But really what we're seeing people now to do to actually get high quality is you want to know, hey, what platform should I be using to build my system? And so people are really moving from these monolithic models to now these compound AI systems. And that FactSet use case that they talked about in the keynote is a perfect example of that, where they basically did a text-to-SQL model. And they weren't getting that good of accuracy with just a single model. And then once they broke it down into smaller steps and modularized it into microservices, it's funny how everything becomes software engineering at the end of the day, then they got way better performance. And then it also makes distributed teamwork easier and everything. So honestly, systems are just the way to go. So again, the other thing that Databricks believes is not only should you build these AI compound systems, but they should leverage your enterprise data. And so this is kind of the path that we see most people take as they're building these compound AI systems. So people start with prompt engineering, and so they see hey, how can a generalized intelligence model perform if I just do some prompt engineering? And so eventually they'll hit a ceiling with prompt engineering, and they'll be like, OK, I actually need to access my enterprise data. And so that's when they move to retrieval augmented generation. There are 5 sessions on RAG at this conference, so I'm not going to go that deep into RAG. So if you did want that, I think there's another session going on right now that I highly recommend, or you'll be able to watch the recording of them. And then even with RAG, people hit the ceiling of quality sometimes. And that's when people start to go into fine tuning. And then if you really want to control the size of your model, what data it has, et cetera, then you go to full pre-training. And so the Shutterstock Image AI model that was announced today is a perfect example of that, where Shutterstock had their photorealistic images of the corporate enterprise workplace. And they built a model from scratch that just used those images, so it could create images that look just like that, rather than who knows what images people are gathering from the internet and the other image models that have been created. And so because of that, they were actually able to produce a pretty small model that has really good latency. All right, okay. So let's get into model training. So Mosaic AI has a model training suite. So the first thing that we allow you to do in GenAI is fine-tuning. The fine-tuning API and the support in the UI, which we'll get to in a second, is now public preview. It is serverless, so everything inside of the Mosaic AI platform is serverless. So you do have to have serverless support. We also may not support your region yet, in which case nicely ask your AE or your SA or Databricks representative that you work with, and then we're using those requests to try to prioritize which region we turn on next. So that's the way to get around that. So fine-tuning is something that you can do to basically improve a system component's performance on a particular task. And so often what we see people are like, Entity extraction, top use case we see here. Some people are doing text to SQL, though as you saw from the keynote, we're building our own kind of text to SQL stuff, so you just gotta stay tuned for that. And then a lot of people are doing things to like match your brand voice or your brand tone. And so many people have like many articles written in their like company voice, or they have like, books written on it, and they want to kind of like emulate that voice, and you can do that with fine tuning as well. Other cases for fine tuning is you can actually teach it to learn, speak a new language and things like that. So we see people like teaching their LLMs Korean or Japanese with fine tuning as well. Pre-training we just talked about is where you're going to fully fine tune this thing from scratch. You're going to give it a huge corpus of documents and then pre-train from scratch. This is like very complicated to do. So most people on their GenAI maturity curve, they're not there yet. So we're just going to skip it. But if you do want to do it, just reach out to Databricks. We're more than happy to help you get started on pre-training this from scratch. And then there's this project called DSPy. I don't know if anyone here has heard about it, but it is allowing you to auto-optimize prompt engineering. And so we just partnered with DSPy, and we're going to be building it more and more into the Mosaic AI platform. It's pitched as like a declarative way to define like LLMs, but really what it's doing is basically a live pipeline that's trying few-shot examples, seeing how it does, and then finding new few-shot examples and putting those in. And so it's this like system that's auto-improving over time by trying different few-shotting prompts to try to improve your prompt engineering. And so that concept is something that we're looking into in Mosaic AI, is how can we create these like almost like live models that are auto-improving over time as better and better data goes through it. All right, so number one question people have is like, when do I fine tune? Like, it sounds great in theory, but like this model seems to be doing good. And so like, I'm just gonna walk through quickly with our fine tuning API where we've seen people be most successful. So often when people start with that prompt engineering part of like the first step of model training is this prompt engineering, they end up building really long prompts. So it's like, oh, in order to get it to do exactly what you want to do, you add another sentence in the prompt, and oh, it didn't quite get that, so you add another one, or you just have like a bajillion business rules in your organization that you're trying to teach it, and so you're putting like hundreds of rules inside of your prompt to be able to manage it. And so you just have these like massive prompts that like you can't manage, you have no idea how you got there. And if something goes wrong, you're like, oh, I don't really know what I need to change in this prompt to fix it. The other thing is most models charge on the number of tokens going in and out of the model. So if you're increasing the number of tokens going in with these long prompts, it's going to start costing you more money. And so if you have use cases that are like this, this is a pretty good sign that you're a good fit for fine tuning. And so fine tuning is basically going to dramatically reduce your prompt size because it's taking all those rules and logic that you're trying to put into that prompt and just baking them into the model itself. And so all you have to do, especially for instruction fine tuning, is you're just creating a pair, a like prompt response pair of what the prompt is, what the response should be, and you just need, we'll talk about it in a second, but for our fine tuning is doing full fine tuning. So you need like maybe like 10,000 pairs. Some people succeed with 5,000, but in the tens of thousands of pairs really starts to improve the quality that you're getting in there. All right, another use case is if you hit a quality ceiling with RAG. So you gave your model access to your enterprise data with the RAG architecture, and now you can't get it to perform any better. You've like hit a ceiling. You've done everything you could to optimize the retriever. You've done everything you could to prompt engineer the text generation model, but it's still just not improving. That's another use case where you can now fine tune the text generation model to make it do question and answering better in there. And I believe they're going to demo that in one of the RAG sessions. The other use case that we see a lot is that you need to have lower latency or lower serving costs. So a lot of these general purpose models are quite large, which is quite expensive to serve. And so if you're building one of these AI compound systems, you can't have a massive model on every step of the chain because that's going to be prohibitively expensive. So what people end up doing is as they're specializing these different components, they're actually trying to find a smaller model that can do that very specific task very well. And then you can get not only a smaller model, so it's smaller serving costs, but also then they get lower latency as well there. So, and we especially see this with people who are having high throughput use cases. So the higher throughput the use case, the more expensive it is to use like the larger models. And so that's where we're seeing people do this. So hopefully these kind of like resonate with you, but if you have any use cases that kind of fall in these categories, these are kind of signs that maybe fine-tuning is going to work for your use case. Oh, this is just, this is from the Databricks State of AI report, which I think just got released yesterday. It's really hard to read this, but just take my word for it. If you read it, it would tell you that most people are using models that are less, like 13 billion parameters or less on our platform. So this is like stats from our actual platform usage. I would say it's kind of breaking recently in here where Llama 370B is so good that most people are playing around with that, but we'll see how many people actually go to production with a model that large. Okay, so let's walk through fine tuning. So let's see where we are. Okay, here we go. So the way to get to fine tuning, so I'm just going to show you the UI version because it's easier to demo, but there is an API, and it's a one-line API, so this is like low code, no code. And you can basically think of it, it's kind of like we're building AutoML for fine tuning, and in fact, that's where we're going to kind of go next with it, so we'll show you that in a second. But you're going to come down to these experiments. When you click experiment, you're going to see that you can now click foundation model training and create one of those experiments. In here, you're going to have 3 options. So you can do chat completion, which is like, hey, make this better at conversations. You can do continued pre-training, which this is that example I was talking about where you want to teach it a new language. So it's basically saying like, hey, general models are only trained up to a certain date. I have like all the like documents that go up to this, like the more recent data. So I was kind of like throw it in there and continue the pre-training of this base model to now also include this new data. So most often people do that for teaching a new language, but you can also do it for like trying to teach it new knowledge as well. And then there's instruction fine tuning, which is saying, hey, given this input, I want you to always return an output that looks like this. And so that's like entity extraction or the match this format exactly in there. So once you choose which of these you want to do, you then choose your base model. So we support a ton of different base models, so Code Llama, DBRX, Llama 2, Llama 3, and Mixtral. So you can choose one of those in there. Llama 3 8B is the one that's most recently supported. Then you choose your training data set from inside of here. I don't actually know which one I have in here. Let's see. Fine tuning, I'm assuming. Oh, wow, perfect. Come on. Oh, here we go. All right. We can select this. Then you can choose your model name. And so here's kind of where the magic happens. You just choose where you want this model to be saved. So you can choose like, what catalog you want it to be saved in, then name your model, like fine-tuned model. And that's it. We choose all the parameters for you. You can change them if you want. You can go to advanced options, like change the training duration, change the learning rate. But we choose the ones that seem to work best for people. And a lot of people just go straight out of the box, click start, and they get pretty good results, and then you can tweak it later. But with that, you can go ahead and click start training. And now it's going to actually train one of these experiments. And if you want to see what one actually looks like when it finishes, you can see in here it's going to create an ML flow run that contains your instruction fine-tuning or fine-tuning run in here. So there's a couple things that we're going to do to improve this in the future, where it's like not fully integrated with MLflow yet. This is part of our sort of Mosaic ML acquisition, where we're like integrating the fine-tuning product in. And so it's just going to keep getting better and better with time. But the core capability is all there. It's just kind of like the nicer features for you to see, hey, what parameters did we try? What was the learning rate? What was the training duration? Those will all be added soon in here as well. All right, so then we can actually see how this performs. So this one was doing instruction fine-tuning to improve text to SQL because the base model was returning too much extra content around it. And so we're gonna go in here and do a little side-by-side. So I'm gonna choose my instruction fine-tuned model in here, and I'm gonna choose the base model for Llama 3 in there, and then we're gonna copy paste this nice in here. And then when we paste it, you'll be able to see my instruction fine-tuned returned just the output I wanted, which was just the SQL. And then it's really hard to actually prove that the SQL is better than the other one, so sorry about that. And then in this one, you can see it returned all this other information. So you could try to prompt engineer it away, but it was very easy to just quickly instruction fine-tune this because we had the data already to be able to create this. So that's how fine-tuning can work, to sort of guarantee your input. And so again, this is really helpful when you're building systems, because you want to make sure each component system has a strict input-output, And so you can actually fine tune these models to kind of give you that behavior as well. All right. Oh, 10 minutes. Oh, we gotta fly. Okay. All right, we're gonna really go through this fast. All right, so the other thing, so when we're building compound AI systems, we have this thing called Agent Framework. Agent Framework is gonna help you, there's gonna be an SDK to it, and right now in public preview, it's actually like a series of 3 notebooks that you just run, and when you run all 3 of these, it's gonna quickly create a RAG endpoint for you. So there's gonna be many sessions on that in this conference, so recommend going to those to learn more about the Agent Framework. We GA'd vector search recently, so you can use vector search is supporting hybrid search and a new embedding model now as well. And then the tools catalog is what we showed this morning in the keynote, and so we'll show that again really cool. We'll do like another quick version of that, take 2. But we're seeing more and more people are moving towards these agent architectures. So what an agent architecture is like instead of building a fixed chain, you're having a chain of thought, logical reasoning LLM that you're giving access to a bunch of tools. And it's figuring out which tool it should call in order to answer the question. And what's kind of nice about this is it basically has like fallbacks built in where if it tries a function and it doesn't work, it's like, oh, I made a mistake. Let me try another one. And so it keeps on trying until it like really wants to succeed. And so it's going through until it succeeds in there. So with that, let's walk through here. So we're just going to really quickly basically go through the keynote demo again. But so in here, we have some like tools that we've created. We now support UC functions as tools, which is super powerful because you can have a SQL function as a tool, so it can directly query data in your data warehouse. It can, you can write a Python function, so you can do business logic, or if you prefer querying in Python, you can do that as well. It supports retrievers, model endpoints, and remote functions. So you can actually call to external services like Slack, PagerDuty, you can file Jira tickets for you, GitHub, et cetera. So you can really connect all these external services with these tools. And they're all centrally governed inside of the Unity catalog, which makes sense because a lot of times they're like interacting with your data and stuff anyways, so might as well govern them all together. So that's an example of how you can see one that has SQL in it, and then if you just want to see, this is actually my RAG endpoint that I created through Agent Framework. And so I'm just calling this endpoint in here directly and then returning that as well. And so that's how you can just wrap a model endpoint in a tool to be able to call it. So now I can come into the playground. We can like click on Llama 3. And so you can use any of these models that have this function icon on it. So really what's the under the hood announcement here is that our model serving now supports function calling. So function calling is basically LLM takes an input and has an output to it. And so you can use this to make it call like various functions. And so in here, this is which tools support function calling. If you did traditional function calling, you would actually have to define a spec. So this is an example of like what the spec would look like if you wanted to let it get the current weather. So you'd have to define this whole spec, and then you'd have to have your function definition somewhere, and then you'd have to provide a secure and scalable compute environment for the LLM to be able to call to actually execute that function. And that's what's actually powerful about this UC tool catalog, is that it's a hosted function on Databricks. So it's using the Databricks secure and scalable compute environment. As you saw when we looked at that function definition, the function and, or actually I can go back. The function and the, you can see here, it has my comment. The function and the spec are in line together. So as you're defining your function, you can actually see this. So let me actually show you even better. Just go into the code. So when I'm, ignore my access tokens that I just raw pasted in here. No one screenshot. Okay, scroll past these. All right. Okay, fine, we'll just do it. So you can see in here, if I define one of these functions, you can see that I'm putting the spec for what it is, so it knows how to map the arguments into the function alongside the definition. And so this is a huge upgrade over how function calling works today. And this is what's nice about tools, is your definition and your spec live together in the same file. And then here's like what it's saying that actually does. It like retrieves the quantity and total sales of products at the given franchise. So this is what makes the UC tools function calling so powerful, and that's what makes it like seem almost magical when it works in the playground. So now if I go back down to playground, choose Llama 3, which Llama 3 right now, at least from my messing around, it seems to be really good at function calling compared to a lot of the other models. Like when I was experimenting, like, this is just vibe check, so don't take my word for it. But vibe check wise, it seemed to work as good as GPT-4 at this. So then I can just give it access, don't do a typo this time, to all of my function or all my tools in this catalog. And then, I can do other ones as well. But so if I go in here and say like, what is the best selling cookie in the San Francisco franchise? It's going to come in here and it's going to figure out. So again, this is where it's doing that chain of thought reasoning where it's going to figure out which tool it needed to call in order to answer this prompt. So the reason it's calling this franchise by city one first is because it actually needs my franchise ID in order to be able to access my sales data. And so you can see here, it executes, like the thing that's happening here that people maybe don't understand is that this is actually executing this query. And so this is what's hard about function calling today is how do you actually attach it to that compute environment to actually execute it. So it's executing this, getting the answer, and continuing forward here. So it's executing all of this. And so this is my enterprise data. It's never leaving Databricks, and now I can get this sort of powerful data intelligence. So this is telling me, hey, it's almond biscotti in here. And so this is really what we're seeing right now, at least. So who knows what happens next in the GenAI world. But right now, this seems to be the way that a lot of these compound AI systems are heading in, is where people can build these modular tools. You can share them across your organization, which is why we have this tool catalog to make it so you can register them, share them across, permission them. And then you just kind of stitch them together. You have this like central brain LLM, and it figures out how to call which one. And honestly, it works pretty dang well. So that's what's very exciting about what we're seeing happening here. Ooh, okay, running out of time. Going back. All right, demo. Okay, we're gonna go through this in like 2 seconds. All right, so the next thing is you now want to operationalize this. And so again, before you can go to production, you need to be able to evaluate this stuff. And it's really hard because it's all using structured data, or if you're using an agent, you could ask it a bajillion questions. So how on earth could you get the coverage that you possibly need here? Great question. And this is why we see most of our customers say, heck with it, straight to prod, and they're just testing it on small groups of things. And so we hear you, it's complicated. We're here to try to help. So the first thing we've done is MLflow works for GenAI. I don't know if everyone knows that, but it does work for GenAI, and it has an mlflow.evaluate command that makes it so you can evaluate and compare models. It provides some very basic metrics out of the box, like toxicity, and I think the Rouge metrics come in it, and then it obviously looks at like tokens and latency. But we now have, as part of our agent evaluation product, it actually will extend those MLflow metrics with AI-assisted metrics. And so we'll give you metrics like correctness or relevance to query that are sort of LLM as a judge-backed metrics to give you sort of like additional quick intuitions into it. And then also, as you saw in the keynote demo, we have this review app that you can send out to any of your business stakeholders who are like the subject matter experts on that topic, who can then chat with your application and then basically provide feedback on whether it was good or not. And all that data is then logged in Unity Catalog. So let's quickly get into that. So here's what the review app looks like. So you can come in here, you can ask it questions, you can thumbs up, thumbs down. You can tell like why you picked no. So like, oh, this is harmful, it was inaccurate, it was poorly structured, and all this information is then stored somewhere, and then whoever the developer is can use it to sort of debug what's going on. So that's that. Okay, we're really cranking for time. And then here is what the evaluated metrics are. So this like agent that I built, I actually tried with a bunch of different models. So I used MLflow to actually right now log all the different base models that I tried and the various temperatures. And then here are my AI-assisted metrics that the agent evaluation gave me. So it gave me this one for correctness. And so it's using LLM as a judge to allow me to see which ones are providing the most correct responses based on an eval data set that I provided to it. That's kind of got you here, is I created an eval data set, and I sent that in, and it's creating these metrics off of that. So if there's one thing you need to do, it's build this eval data set. So that's why we showed the payload logging table, things like that, because you need to kind of build this eval data set. And the review app can also be used to get the eval data set from your subject matter experts. And then we have this relevance to query. And so in here, I can kind of compare. If you're not really a table person, there's this chart icon over here. And so if you click that, you can actually see we built like MLflow has this like in dashboarding ability. or you can actually come in here and see. Sorry, I'm gonna have to zoom out so it looks better for you all out there. So you can see in here, you can compare which one, and then you can see, oh, Llama 3 seems to be doing pretty good. In fact, it's even beating GPT 3.5 for this use case on this eval data set. Disclaimer, disclaimer. Okay. So that's the AI-assisted metrics and how you can do evaluation and sort of like build up a more robust system around testing quality. Again, LM as a judge isn't perfect, but at least it can give you some quick intuitions into like, hey, where do you need to dig into next? And then the other thing to quickly bring up is ML flow tracing. So ML flow, it's really easy use. Like if you're familiar with auto logging in ML flow, you just set up auto logging again in your notebook, and then it will automatically like log these traces. You can additionally like decorate different methods, especially if like some crazy stuff going on. You can decorate them with I can't remember the exact syntax, but something like @trace or something like that. That then will like trace that method for you, and you don't have to add anything other than these decorators, and they'll automatically get tracked in there for you. And so here was like a use case where I'm hallucinating. And here where it says these cookies exist, but they don't. And so you can actually dig through this entire stack trace to see, hey, what's going wrong? You went all the way down to actually the vector store retrieval to see, hey, what is the vector store retrieving here? Okay, I'm at time, so blah, 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 blah. You can do lakehouse monitoring. It's going to be great. And here are some other great sessions that you may want to visit. It's hard to tell what they are, so I added in pink like what the topic really is in these sessions for you all. With that, I hope the Mosaic AI platform makes sense to you now and what we're able to do to help you get from data all the way to production. If you have any questions, you can come find me outside. And thank you all for coming. And thank you for being at GenAI Summit.